All right. Hello, everyone. Good morning. Thank you so much for being here, for joining me today. And I'm excited to be here at Big Data London with all of you. So today we're going to discuss one of the most interesting shifts that we are all seeing nowadays. And that is moving into a modern data lakehouse, into a modern data architecture. And so in the next over 30 minutes or so, we're going to discuss some of those shifts, the reasons behind it, the latest trends. We'll talk about Apache Iceberg as a playing role as part of this architecture, and how to transform your organizations, and if you're part of data teams, why you need to act today to move into this new architecture. So my name is Guy Fighel. I'm a technical entrepreneur. I work in the data field and AI for many, many years. My latest role was SVP of Data and AI for a company called New Relic in the US. Nowadays, I'm an investor working with innovating teams on incubation projects and investing in those projects as part of Hetz Ventures, which is a leading venture fund. So just to set the stage here, and as part of what we've discussed, we'll first look at the current landscape, what's been out there in the past. We'll explore the needs into a modern data lake and why this shift is happening. And finally, we'll also discuss what the future holds, and why, again, we all need to start paying much more attention to this new architecture and how we can prepare our organizations and companies for that. So in the beginning, and this is probably something that you're all aware of, we've seen clear evolution in how organizations are managing their data. Traditional data warehouse was a great, especially for structured data. And as company evolved and the data types have evolved, this became an issue. Unstructured data was no longer possible to be saved and processed into those warehouses. So we've seen a clear evolution in how organizations managing their data. And so what were the changes that evolved those organizations? In the past, most of the data that we were all working with, the data types were structured data types. And as you can see, they have great benefits, but as the business evolved, different types of semi-structured and non-structured data types needed to be processed. Some examples, if you in your organization needs to run some machine learning models on vision, then the photos, the picture themselves are no longer a structured data. And you probably want to process some of the metadata on the photos. Those are kind of semi-structured. And then how do you connect all of that with the structured data that you already have? So the layer of the kind of old way of doing things is basically put everything in a single warehouse, and maybe the data types that could not fit into the warehouse, you would basically put in a different database and try to connect. Basically turned the entire processing into something very cumbersome and takes much more resources and time with less control and governance. And many organizations today look something like that. It's a mix of a situation. So they're really struggling with the fragmented data ecosystem. And basically what you can see is that the organization and shift in data teams to support different other teams and business teams in the organization causes a proliferation of data sources. Some teams, for example, a marketing team has a data analyst or data engineer or some type of a team that is helping them. Same goes for marketing, for sales, for product. And not all of those teams are coming into an agreement on a specific technology and specific schema. And so each team evolves into a different types of a data product type, uses different technologies. Obviously, you're losing governance, you're losing product definitions, and it even comes into a situation where teams cannot really agree on data definitions and on schemas. So then it's a big problem on how do you query that data between the different teams. Even if you have a centralized data product team or a centralized data engineering team that already made a decision to move into something like an Iceberg format, which we'll talk about, using Snowflake, Databricks, or any of the other technologies, you still have those kind of like data siloed teams, shadow data teams that are using other technologies, and it's very hard to overcome. So moving into a modern data lakehouse solves a lot of those issues. So the emergence of data lakes allowed you to handle both structured and unstructured data, but without the proper governance, right? So it's the kind of the middle layer of the diagram, right? So companies understood that, moved and shifted from a warehouse architecture into a lakehouse architecture, but still kind of used it in the same old way. So the main benefit of that is that storage and compute are completely decoupled from each other. So that's a big benefit. And the second benefit was openness and the storage format and the direct API calls. When companies are moving now into a Delta Lake or a complete new lake type of architecture, they're able to benefit, to take those benefits and even go farther along, and we'll talk about that. So first, really know the different differences or different options when you are trying to make up a decision. How do you migrate your warehouse? Is it into a lake architecture? Is it into a data lakehouse architecture? Or is it like a full data lake architecture? And data lake, you can definitely use an open source data lake. It doesn't mean that you have to use Databricks. But for each type of storage and architecture, there are different needs and uses. And as Gartner put it, by 2025, 80% of the organizations will move their analytics workloads into the cloud. And so as all of our organizations are moving into a different types of an architecture, choose the right one for you. And maybe not necessarily a data lakehouse is the one for you. Maybe it's data lake. But you have the options to understand which one is it for you. And we can dive a little bit even deeper and talk about the core components of this modern architecture, which is the use of open data formats. And there are multiple data formats, but three that worth talking about here and mentioning here is Avro, OCR, and Parquet. They're all open source to begin with, so huge community, and each one can perform separately from your open table format and from the actual storage layer, right? So you can definitely have, for example, choose an object store in Google Cloud, in GCS, use an Avro for optimized ETL processing, which Avro is excelled in that. Use for different sets of tables, Parquet for fast reads and fast SQL reads, which Parquet excels in. And then all of that connected all together into an open format table managed by Iceberg. And we'll talk about that. And again, it doesn't mean that you need to dump your Snowflake because they have integration into Iceberg. And if you choose to process things in Databricks or in any other platform, you can still do that. Basically, the multi-layer architecture of separation between open table format, the open file format, and the object store format is the key in migrating into a data lake new architecture versus a closed source type warehouse architecture. I'm not going to go into all the bits and bytes of how Apache Iceberg works, but if there's only one thing that you can take out of this presentation is multi-layer approach in Apache Iceberg as an open table. You have the data section, you have the metadata, and then you have the catalog. Each points to the other one. And the data itself, the data layer, is basically the files. And those files contain the actual data. The metadata section and layer is more complex. It contains multiple layers inside. But basically, think about different pointers and a description of how the tables, how the schema looks like, what is the open source format that you're using? Are you using Avro or Parquet? And you can use multiple of those. And then a pointer to a deleted files as well. With Iceberg, it's really important to understand you get this consistency. It's an ACID, basically guarantee, which means that if you are deleting a data, there is a new data, there is a new file in the data layer that will be created with the deleted data so that you can always revert back. And that's one of the great options for Iceberg as well. And the catalog is what wraps all of it and creates it an open connector to any of the other solutions in the ecosystems that supports the Iceberg format overall. So multiple benefits here. Again, you can use basically a separation between Iceberg, the file format, and the object store. For each of your use cases, you can choose a different solution, and it's all being part of this huge lakehouse architecture that we're all talking about. So why this shift is inevitable? First and foremost, organizations need to eliminate silos, and that's the number one reason for that. If we saw before the different shadow data teams that each one uses their own technologies, by bringing all of them into the same modern data architecture, we're getting rid of those silos. We have more data sources than ever, and combining them into a single accessible environment is essential for innovation of company. Now, data teams, no matter in which department they are serving, can choose the right technology for them. They can choose whether they want to store the data in GCS or in S3, and maybe in multiple cloud technologies. Basically plug into Iceberg as the common denominator across the organization, choose their own data engine, whether they want to use a direct connection through Snowflake, or do they want to use something completely open source like Trino or Dask or any of the other engines, and then have a fully accessible API to basically query using those data engines through the open table format and into the storage layer. It's a completely new approach to how you're architecting your data engineering and infrastructure. And the last is data mesh. Then data mesh principles are becoming more and more prominent. It's a concept of decentralized team. Each team owns an end-to-end data product. This is the only architecture that can really support that without duplication of data and without huge cost. In that model, data will never move and will never get duplicated. What changes is the schema and how the data products are getting access through APIs and the different schemas and the different formats managed by Iceberg. It's a huge cost saving for organizations, and it's a huge simplification. Putting on top of that governance and semantic layer brings a true single source of truth across your organization, which you couldn't accomplish before. Again, I've talked about data teams, and I've talked about data mesh. You can see it here. But basically, every team can consume from a centralized platform. They can produce to a centralized platform. There is a domain expert that can basically define all the structure of the data product itself while using the resources and the generic resources offered by the data platforms, again, without risking costs, governance, security issues, and without basically inventing their own wheel and different structures. So how do we get there? I know that all of you are coming from different organizations, different companies, different data types, and it's very hard to actually go and now make a change. So it's a really big change management requirement. So first, my first recommendation is interoperability with your existing stack. I'm sure that some of you are using already Snowflake, Databricks, some ETL vendors. They are all moved into this new architecture. They all have plugins and they all support this new Apache Iceberg architecture and all the data, open data formats that I've talked about before. So first, reach out to those vendors and basically see what they can offer before you go and kind of explore further. Choose your own stack, what really, really works for you. Different data engines, it's fine. Not all the data engines are the same. You can choose your own as long as it supports Iceberg as its core component. So you basically have to just choose one thing. I'm going to move my organization, my entire data engineering, to use Iceberg as my open format, table format, and I'm going to build around that, whether it's with my existing vendors, new vendors, open source vendors, or just a pure Python code that I'm going to write against it. Very important is to establish semantic consistency. Definitions. What is the sales price? Do I establish it as sales underscore price, or is it S-price? Some teams use that. The other teams use a different semantic definition. So a consistency here is the key. That's what really contributes to the governance, that all of the teams across get the same results when they need to calculate something. So Cube.dev as an open source project, can definitely take a look at that. They also established a company out of it as a managed resource. And all right, good. And then seek for real world examples, right? There are a lot of different materials and blog posts about how people have migrated into this new architecture and have shifted. And move in steps. One of the things that I really like is establishing the CDC architecture. Check out the Bezium as one option. Basically, you already know you have some siloed data in your organization. You build your Apache Iceberg and you build your new lakehouse. Now there is a question, how am I going to move all of those siloed teams into the warehouse, into the lakehouse? So one option is to use the Bezium as an option. It's an open source project as well. And that basically a synchronization between those old type tables and formats into the new lake formats and keeping those in sync until you can basically move completely and move your query engines to use your lakehouse directly. So in what's the future looks like. I really love this representation. I didn't put it together, but it's an amazing representation. This is where companies are moving towards. If you ask me how the world will look like in 5 years from now, probably most organizations will look something like that. They will choose multiple data engines, Trino, Snowflake, Databricks, etc. It will all be based on open format Iceberg table. We'll reach a single source of truth based on that, and then find different object stores to store their information, which will take their cost dramatically down. I'm sure that the open data formats themselves will advance. If now, Parquet and Avro are almost de facto, and for most of the needs, I'm sure them themselves will get enhanced in compression, in performance, and some others, new ones, will come into place. And I'm sure that AI and machine learning will become a big part of it. We are already seeing models connected directly on top of that type of an architecture, so they can work in real time and update the model frequently. It doesn't matter if those are LLM models or different models. They're all connected through an API layer through that architecture. And with that, to wrap up, we've covered a lot of ground today. We've looked at why the shift to modern data lake architecture is inevitable, the trends driving it. We've talked about adopting different approaches, talked about open formats, and Apache Iceberg as the key enabler for this shift. And if you are in the space, you cannot ignore it. You really have to act now and start thinking about moving your data architecture into the next generation. Thank you so much. If you are interested in joining our innovation program, please click on the QR code. If you are innovating in the space and would love to talk to me or to any one of us, very happy to do that. And also, if you're a professional in the space and you would love to advise other companies and other founders building in the space, please reach out. Thank you so much for being with me today.